Okay, let's take a look at the past paper questions then. Okay, so this one is from 2022 and it's worth 3 marks. Just simple differentiation. So differentiate the square root of x cubed minus 2x to the power minus 1. So let's prepare for differentiation. So that's going to give me y is equal to x to the power 3 halves minus 2x to the power minus 1. So differentiate to find dy by dx, and we get 3 halves x to the power of a half plus 2x to the power minus 2. And that's absolutely fine for your 3 marks. Okay? You're absolutely fine to leave it like that. If you wanted to, you could go ahead and put it into, write it with positive powers. You don't have to at all. And it would give you 3 root x over 2 plus 2 over x squared. I wouldn't recommend doing it if you're dodgy with your index laws, so you would be absolutely fine to just leave it there. Okay. Past paper example 2. This is from way back in 2004. So it says that I want to find the value of x for which the gradient to the tangent is 12. So we're talking about gradient of tangent being 12. That means that dy by dx is equal to 12. Remember, gradient is the derivative, which is the rate of change. So dy by dx is equal to 12. So for part A, let's find what dy by dx is. So differentiate my equation. So I'm going to get 12x minus 3x squared. So that will give me minus 3x squared plus 12x is equal to 12. When I do my dy by dx equals dy by dx. Let's bring it all over to one side. So I get 3x squared minus 12x plus 12 is equal to 0. Factorise it. Common factor comes out first, so 3. X squared minus 4x plus 4 equals 0. Further factorise, so we get 3 bracket x minus 2. X minus 2 is equal to 0. So therefore, x has to be 2. Okay? That was only possible because I knew that if my gradient is 12, my dy by dx is 12. Part B, it says, hence find the equation of the tangent. So when x is equal to 2, I want to sub that into the original equation to get the corresponding y value. So I'm going to get y is equal to 6 times 2 squared minus 2 cubed. So it's going to be 24 take away 8, which is 16. So I've got a coordinate of 216. So put it into y minus b now. So y minus b is equal to m bracket x minus 8. So y minus 16 is equal to 12 bracket x minus 2. So that would be y is equal to 12x minus 24 plus the 16, which gives us altogether y is equal to 12x minus 8. Okay? So I think you'll agree at this stage now that when you look at the past paper questions, they do seem pretty straightforward. Okay? And it's something you really should be doing now, going through your past papers. The final one here, past paper example 3, this is from 2016. Find the x coordinates of the stationary points. So stationary points, but I just want the x values. So part A, let's go ahead and do that. So we're going to differentiate dy by dx is equal to 3x squared plus 6x take away 24. Now we know that stationary points occur when dy by dx is equal to 0. Okay, so that gives us 3x squared plus 6x, take away 24 is equal to 0. So that's 3 brackets x squared plus 2x minus 8 is equal to 0. Factorise it further, so we get x plus 4, x minus 2 in the brackets. So x is equal to negative 4 and x is equal to 2. Okay, and that's enough for part A. That's our x coordinates of the stationary points. Part B gets us to determine the nature. So for that we need a nature table. So let's quickly just draw it up. So we are approaching minus 4, approaching 2 and then leaving 2. Put in your zeros, put in your derivative and shape. Pick values before, between and after. So we have, I'll put minus 5 in here, 0 in here, and then 3 in there. So if I put minus 5 into my derivative, I get a positive number. If I put 0 in, I get a negative number. If I put 3 in, I get a positive number. So it's going to be up, along, down, along, and up. I want to know when is the curve increasing. So it's increasing. Let me just underline that a bit better. It's increasing when, well, it's when we're, before we get to the first stationary point, then after we leave the second stationary point. So it's increasing when x is less than negative 4 and x is bigger than 2. Okay? And that is basic differentiation.